Let's consider the following problem. A bullet of given mass strikes a block of given mass, as shown here. Assuming that the bullet remains embedded in the block, calculate the bullet's initial speed v1 if the block immediately after collision moves at given speed. Neglect friction between the block and surface and the gravitational force on the bullet. One of my students suggested the following solution. First, he considered bullet and block as a system, and there are two external forces on this system. First is force of gravity on the block, then normal force on the block, and we neglect gravitational force on the bullet. Because there is no vertical motion here, these two forces should cancel each other, so the magnitudes are equal and net force on the system is 0. Starting from here, the student decided that mechanical energy of the system, which is the sum of kinetic and potential energy, is a constant. Because block moves along the horizontal surface, we can select potential energy equal 0, and from here we have that kinetic energy of the system is a constant. It means that for any initial and final states, we can say that initial kinetic energy is equal final kinetic energy. Now, initial kinetic energy is equal kinetic energy of the bullet and is given by this formula. In the final state, when the bullet is in the block and starts to move together with block with the speed v2, kinetic energy is given by this formula. Here m capital plus m is the total mass of the block and bullet system. So we use the fact that these two kinetic energies are equal, and the student got the following equation from which he was able to find v1. So simple algebra leads to this answer. We know all numbers here, and we finally get the answer. v1 is 17 meters per second. And this is solution of first student. And the second student suggested another solution. His solution started with the same analysis. So he considered the system of bullet and block, analyzed forces, and came to conclusion that F net equals 0. And from this conclusion, he wrote equation that linear momentum of the system is a constant. And then he considered the motion along x-axis, which is horizontal axis. For this motion, px equal constant, and initial linear momentum x component and final x component are equal. Then he wrote equation for initial linear momentum. It is just product mass of the bullet times speed of the bullet. Then for final state, linear momentum x component is given by this equation, where m capital plus m is the total mass of the system. Then he plugged this right-hand sides to equation for x component of linear momentum and got equation from which he found v1. The numbers here he plugged in this equation, and the final answer is v1 is 241 meters per second. So we have two different answers to the problem. First answer was provided by the first student is V1 is 17 meters per second, and the second answer, this speed is 241 meters per second. The difference is very big. Which answer is correct? So which solution is correct? To answer this equation, let's analyze the first solution. So the main assumption which student made was that kinetic energy conserves in this situation. Let's consider in more details. When a bullet moves toward block, they collides with block and stops inside the block. Why it happened? It happened because during this motion inside the block appears the force which points in opposite direction to velocity of bullet, and this force actually is a force of kinetic friction. We know that kinetic friction force is non-conservative. What does it mean? It means that when a kinetic frictional force acts within the system, then the mechanical energy of system changes. So mechanical energy is not a constant. So this conclusion made by the student is incorrect. And as a consequence, first solution is incorrect. Now let's analyze the second solution. Here the student used the law of conservation of linear momentum, which is a consequence that net external force on the system is equal to 0. In our case, kinetic friction, which acts on the bullet inside the block, is internal force. Let's read now the formulation of the law of conservation linear momentum. If no net external force acts on a system, the total linear momentum P of the system cannot change. In this formulation, there is no any words about internal force. It means that this statement is valid for any internal forces. And in particular, it is valid in our case of internal frictional force. So the second solution is correct. Initial speed of the bullet is 241 meters per second. If you like this video, you may want to click like icon, leave a comment and subscribe for the channel.